Today we will be solving one more problem on the concept of shear force and the bending moment diagrams. We have an example 6.8 and now we have again a cantilever beam. It is subjected to a 2 kN load at its free end and 1.5 kN per meter load intensity, uniformly distributed load intensity of 1.5 kN per meter from its fixed end to a length of 2 meter across its span, and the span of the beam is 2 plus 2, that is 4 meter. We have been asked to draw the shear force and the bending moment diagram. Now again we'll use the same procedure as we have already discussed, as we have already understood the concept for drawing the shear force and the bending moment diagram. First of all, what we will be doing, we'll be obtaining the reactions at the fixed end. We know at the fixed end of a cantilever beam we have a moment reaction MA and we have the reaction force RA. Now what we'll be doing, writing the equilibrium equations. So first of all we have RA acting upwards, we assume to be positive, and 2 kN acting downwards, that is minus 2 kN, and the load and the resultant load because of uniformly distributed load, that will be 1.5 kN per meter multiplied by 2 meter, that is 1.5 kN per meter multiplied by 2 meter. The load is acting downwards. So from this equation we obtain RA is equal to 5 Newton. This is the equilibrium equation. We have to write this to be equal to 0, so we obtain RA equal to 5 kN. Now again the moment equation, second equation of equilibrium, the moment because of first of all the moment because of this 1.5 kN per meter of uniformly distributed load, it will be 1.5 kN per meter multiplied by 2 meter multiplied by the perpendicular distance, or what we call as a force arm. We know this is a uniformly distributed load. Its resultant will be acting at the centroid, so the distance of the centroid from the fixed end will be half of the base of this rectangle, and that's 1 meter. So this is 1.5 kN per meter multiplied by 2 meter multiplied by 1 meter. So this load tries to rotate the beam in the clockwise direction. That's why we're writing this as minus. And the moment because of this 2 kN load will be 2 kN multiplied by 4 meter, again trying to rotate it clockwise. That's why this is minus. So this is 2 kN multiplied by 4 meter. The resultant has to be equal to 0 for equilibrium condition. So from this we obtain MA is equal to 11 kN.